Dive to the sea floor, and you enter an incredible world. It's home to vast volcanoes, temperatures hot enough to melt lead, the longest living animals on the planet, and undersea earthquakes so powerful they send deadly waves smashing into land thousands of miles away. Now, Naked Science takes you on a journey from the ocean's surface to its farthest depth. On a quest to discover what lies at the bottom of the sea. The Earth. The oceans dominate our planet. Nearly 2/3 of the Earth's surface is covered by seawater. 140 million square miles. 353 trillion gallons of water. But if we drain all this water, an astonishing landscape appears. As many as 100,000 volcanoes, called seamounts, the longest mountain range on the planet, and 22 deep ocean trenches. Some plunge deeper than Mount Everest is high. The ocean floor is one of the most geologically active regions on the planet. To understand what creates it, we must dive to the very bottom of the sea. From the ocean's surface to its deepest depth is a distance of 7 miles. That may not seem so far, but getting down there is a challenging and treacherous business. More people have traveled to the moon than have ever ventured to the deep ocean.
The ocean should scare you. The ocean should scare everybody.
The pressures are intense, 4,000 to 5,000 pounds per square inch.
Which is why it's one of the last great unexplored frontiers on Earth. To get an idea of the true scale of the deep, imagine a diver swimming all the way down to the ocean's greatest depth. We're going to follow her on her imaginary journey to the bottom of the sea. It will take us to some of the most extraordinary features on Earth. The shelves, ridges, plains, and trenches of the ocean. Culminating in the deepest point of all, 7 miles below the surface. It's an impossible journey, but if you could make it, what landscapes would you pass on the way? What would this strange underwater world look like? Our first destination, not far below the surface, is the continental shelf. Surrounding nearly all continents, the continental shelf is a shallow ledge that stretches on average 50 miles out to sea. It's not very deep. On average, it lies just 440 feet below the surface. Build the Empire State Building here, and the top half would stick out of the water. But it contains a stunning landscape. Giant ravines pierce the shelf, and they're huge. Many, like the Monterey Canyon off the coast of California, are as deep and as wide as the Grand Canyon. Most are created in the last ice age. 20,000 years ago, water freezes into polar ice sheets several miles thick. As water becomes locked up in ice, the sea level around the world drops as much as 400 feet. The continental shelf becomes dry land on the edge of the continent. Rivers that once flowed gently to the sea now have to drop an extra 400 feet. They turn into raging torrents and carve giant canyons through the rock. When the Ice Age ends, the ice sheets melt and the rising sea buries this part of the coast, creating the continental shelf. The giant canyons disappear from view. Where the continental shelf ends, it drops off in a gentle incline called the continental slope, and that's where we're heading next. As we dive deeper, the light fades. Around a third of a mile down, the temperature drops abruptly to a chilling 39 degrees. And the pressure becomes intense, enough to nearly squash a soccer ball to the size of a baseball. In this extreme environment, strange things begin to happen on the seafloor. The 1980s, geologists start scanning the continental shelves and slopes with side-scan sonar. They find they are riddled with strange features. Giant craters thought to form when gas suddenly escapes from the sea floor. Some people even speculate that escaping gas could sink ships and may explain the mysteries of the Bermuda Triangle. Gas escapes are certainly dangerous. This oil rig off the coast of Norway is sinking into a bubbling sea of gas. The gas pours out after the rig's drill hit a pocket of methane gas. Hazards like this send geologists racing to explore the seafloor. On the edge of the continental shelf in the Gulf of Mexico, a team of scientists prepare to dive. Their mission: to investigate a strange substance that could be causing gas emissions from the seabed. Protected inside the 5-inch thick acrylic sphere of the Johnson Sea Link submarine, they plunge to the continental slope. 1,800 feet down, they find what they're looking for. A mound of a yellowish-white icy substance called methane hydrate. It forms under intense pressure at depths greater than 1,000 feet, and it contains gas. At Heriot-Watt University in Scotland, geologist Ross Anderson studies methane hydrate. Although methane hydrate is mainly made of water, it contains a lot of methane, as Ross Anderson is about to demonstrate. This gas burns, but don't try this at home.
It's actually slightly warm, but the cold water, as it melts, is cooling my hand. So right underneath it, it feels very cold, in fact. But I can feel the warmth of the flames where my hand is dry.
Methane hydrate holds so much gas that every cubic inch of ice releases 160 cubic inches of methane. Deep down on the continental slope, the gas is normally safely locked up in the methane hydrate. But if the temperature or pressure change, the hydrate can melt and the gas escapes. Its sudden release can cause blowout craters. But some people think it could do far worse. Research suggests it could sink a ship. At Monash University in Australia, physicists carry out an experiment in a test tank. They launch a bubble at a scale model boat. If the boat's in the wrong place at the wrong time, it sinks again and again. No one has ever reported a ship sunk by a gas bubble, but some people think methane hydrate might explain the disappearance of ships in the Bermuda Triangle. And methane hydrate is grabbing attention for another reason. Around the world, it's estimated there are up to 400 million trillion cubic feet of methane hydrate buried in the continental shelves and elsewhere in the ocean. By some estimates, that's more than twice as much energy as all the world's oil, gas, and coal reserves. It's difficult to extract, but this strange substance could be the fuel source for the future. The complex geology of the continental slope produces some of the weirdest features on our planet. 2,000 feet down, in the midst of the barren sea floor, the Johnson Sea Link submarine finds something that seems to upturn the laws of physics. A pond of water with ripples on its surface. Biologist Chuck Fisher of Penn State University studies this strange underwater lake known as a brine pool.
Coming up on the brine pool in the Gulf of Mexico is a fantastic experience because here you are on the seafloor in a submarine, very aware that you're on the bottom of the ocean, and all of a sudden you come upon a lake.
Salt solution or brine seeping from nearby rocks fills the crater. The brine is 5 times saltier than the surrounding seawater, and so is dense enough to sit in the crater and form an underwater pool.
The brine is so dense, the submarine floats on the surface of the brine pool. Little ripples go off from the side, and the animals around the edges are bumping up and down. So it's a very surrealistic experience.
Methane gas bubbles up through the water in the pool. High levels of it would kill most animals, but for the creatures that live here, it's the key to their survival.
We know you can get energy from methane gas because we all use it to cook with on our gas stoves at home. But to have an animal that could harness that energy directly and grow with the help of bacteria was a unique thing.
The thousands of mussels that live around the edge of the pond contain bacteria that consume the gas and turn it into food. You might expect that life would struggle to survive in this environment, so hostile to humans. Yet a host of strange creatures thrive on the gases that seep out of the continental slope. Perhaps the best evidence that it's a healthy place to live comes from one of the strangest creatures of all, tube worms. They grow over 6 feet long. Scientists marvel at their size and are astonished when they figure out their age. They determine how old they are by measuring how fast they grow. They first stain the tops of the worms blue. Then, over a year later, they return and measure the white new growth at the tip of the tube. They find that the longest worms grow less than 1/4 of an inch per year. They are believed to be the longest living animals on the planet. Some of these worms started growing 250 years ago, before the American Revolution. They're evidence that life can flourish at extreme depths. But conditions are about to get much more hostile. As we continue our journey to the bottom of the ocean, we're about to encounter the largest single volcanic feature on the planet. A fiery inferno that circles the globe. World War II and the battle at sea is at its height. In the hunt to find enemy submarines, sonar is fitted to Navy ships. Between engagements, they cruise the ocean, surveying the sea floor. The information remains classified for years. But in 1977, cartographer Marie Tharp and geologist Bruce Hazen combine the World War II echo soundings with new data and create the first map of the world's seafloor. This map is the first to reveal the largest single volcanic feature on the planet, the Mid-Ocean Ridge. It rises 12,000 feet from the bottom of the sea, wraps around the Earth like the seam on a baseball, and stretches for almost 40,000 miles. It's 4 times the length of the Andes, Rockies, and Himalaya mountains combined. The Mid-Ocean Ridge is the next stop on our divers' imaginary journey to the bottom of the ocean. It lies 1.5 miles below the waves. No light reaches here from the surface. The temperature is teeth-chatteringly cold. It's a formidable environment. One of the few people to have visited the ridge is marine geologist Deborah Kelly.
The landscape is really remarkable. I used to study volcanoes on land, so it's one of my great joys to be down there.
Today, Kelly is diving to the mid-ocean ridge in the East Pacific. As she begins the journey to the sea floor, the crew turn off the submersible lights to conserve energy. For the 1.5-hour descent, their only companions are ghostly creatures.
When you're going through the water column, there's a lot of organisms in the water that are bioluminescent. The way that I first thought of it was like if you went to space looking at the stars.
300 feet from the bottom, they turn the lights back on.
And then all of a sudden, this world opens up.
This is the inferno of the mid-ocean ridge. Fueled by immense heat coming from deep inside the earth, massive volcanic chimneys, called black smokers, billow out what looks like black smoke. This suite of undersea hot springs is known as a hydrothermal vent field. There are around 80 chimneys in this field. Some rise almost as high as the deck of San Francisco's Golden Gate Bridge, some 180 feet. The water pouring out of the chimneys is superheated. The crushing pressure of 1.5 miles of ocean means the water doesn't boil, but stays liquid, even though its temperature reaches 750 degrees Fahrenheit. It's not only hot, it's acidic.
How do you sample a fluid that's 400 degrees C? Any aluminum will dissolve in a day. Anything that's made out of quartz will dissolve. Lead will melt.
The smokers are black because the hot liquid contains minerals such as metal sulfide. When these hit the near-freezing water of the deep ocean, they form billions of tiny black particles that look like smoke. But how do these chimneys grow? Many of us are familiar with Old Faithful in Yellowstone National Park. This famous geyser erupts several times a day. It spouts a column of water heated by volcanic rock deep within the Earth's crust. These chimneys are like underwater geysers. Seawater seeps down through cracks in the sea floor. Several miles below, it comes in contact with hot magma. It heats up and rises to the surface, bringing minerals with it. When they meet cold water, these minerals crystallize and stick to the top of the vent, and so the chimney grows. But it won't necessarily last for long. In 1 year, 12,000 earthquakes rocked this part of the Juan de Fuca Ridge, a sign of the volcanic activity deep below. Most are small, but some have the power to knock down chimneys. Just how fast these chimneys could grow back is revealed when Kelly and her team decide to cut the top off a black smoker. The crew rig a robotic submersible armed with a chainsaw. The submersible lowers a cage onto the top of the chimney, secures it with wire, and the sawing begins. Now that's a sample. When they go back 3 days later, the chimney has grown a staggering 6 feet. To us, the collection of chemicals spewed out by the vents would be deadly. But for the right kind of creatures, The vents are an oasis in a desert. The energy spewing out of black smokers is phenomenal. The vents discovered so far release about 17,000 billion watts of power. That's almost equivalent to the total energy all the humans in the world consume in 1 year. The heat gives us a glimpse of the powerful forces that create the mid-ocean ridge. To explain a feature as big as this calls for a big theory. In the 1960s, geologists put forward one of the most radical ideas in the history of science. They suggest that the mid-ocean ridge is a vast crack where the Earth's crust is splitting apart. Geologist Susan Humphreys of the Woods Hole Oceanographic Institution studies the mid-ocean ridge.
When you think about the Earth as a whole, you come to realize that this crust that we're living on is incredibly thin compared to the rest of the Earth. It's probably no thicker than the skin of an onion.
If you were to look inside the Earth, you'd find that it consists of layers. A central core, a thick overlying mantle, and a thin outer crust. Vast plates of rock form that thin outer crust. Where these split apart, molten material from deep in the Earth can rise to the surface to form new crust. And that's what happens at the mid-ocean ridge. It's like a giant, never-healing scar that is constantly oozing new material, creating new seafloor that travels away from the ridge. For all their power and beauty, the smokers and chimneys of the mid-ocean ridge tell only a small part of the story of what's going on 1.5 miles below the ocean surface. The new seafloor created at the ridge is about to embark on an epic journey. Over millions of years, it will travel thousands of miles like a giant conveyor belt, then descend at deep-sea trenches back into the Earth's mantle. It's a slow process, but over time, it adds up. The mid-ocean ridges add almost 1 square mile of new crust to the ocean floor every year. That's an amount of new land equal to the area of Texas almost every 280,000 years, or a complete new ocean floor every 200 million years. To follow the journey of the seafloor as it moves away from the mid-ocean ridge, we must dive deeper. We're about to enter the abyss, the graveyard of the ocean, a ghostly landscape built of the skeletons of everything that sinks here. Hold your breath. We're on a journey to the bottom of the ocean. From the strange geology of the continental shelf, past the black smokers on the mid-ocean ridge, we're heading into the abyss. Almost 2.5 miles down, we pass the wreck of the Titanic. And then we're there. The seafloor between 2.5 and 3.8 miles down is known as the abyssal plain. The pressure here is phenomenal, enough to crush a soccer ball nearly to the size of a marble. This is home to the largest landscape on our planet. Put together, the abyssal plains make up more than 60% of the Earth's surface. This is the graveyard of the ocean. No sunlight penetrates this deep, but everything that sinks in the sea above comes to rest here. Ships, sea creatures, and snow. Drive along the seafloor of the abyss, and you drive through a blizzard, a snowstorm that has continued non-stop for thousands of years. This is marine snow, and it creates the flat seafloor of the abyssal plains. When tiny plants and animals living in the upper part of the ocean die, their skeletons start to sink. On their own, the cells of these plants are so small and light, they would typically take over 150 years to reach the sea floor. many would dissolve before they got there. But scientists find that when glued together with the sticky mucus from small plants, called phytoplankton, they form large clumps that can sink in only a few weeks. This is marine snow. The flurry of marine snowflakes carries 815 million tons of carbon to the sea floor each year. For the animals that live here, it's like manna from heaven. They rely on it for food. Over thousands of years, marine snow and other sediment build up into a thick layer. When geologists drill through the sea floor in the abyssal plains, they have to drill through several hundred feet of sediment before they hit bedrock. They bring up core after core of gas-oozing mud, the remains of marine snow and other detritus. From top to bottom, the core of sediment from the deepest drill hole stretches for 3 miles. That's 11 times the height of the Empire State Building. Down here, wrecks of Spanish galleons and other sunken ships take thousands of years to disintegrate. But they're not the only things decaying on the seafloor. Whales live in the top mile of ocean. But when they die, their bodies will usually sink. 69,000 whales die every year. The vast majority sink to the abyssal plain. A team of scientists from Monterey Bay Aquarium Research Institute are investigating what happens to these whale carcasses as they decay. Today, they are paying a visit to a dead young blue whale. They're hoping that its remains, lying off the coast of California, will yield new information about life in the deep ocean. The ship's high-tech robotic submersible will act as their eyes and arms in the deep sea. It launches through an opening in the ship's hull. Over 3,000 feet down, the whale's bones are laid out perfectly, like a museum display. A whale carcass goes through a series of stages. The main scavengers, sharks and hagfish, are gone within a year once they've eaten the first course, the soft tissue. But it's the creatures that move in for the main course that give a real insight into this strange world. These tiny, red, hair-like creatures are here to capitalize on the juicy bones. Marine biologist Bob Vryenhoek studies these worms.
As the bones start to decay, inside of the bones, there's a massive reserve of fat. This is why your mother and your grandmother threw a nice old beef shank in the soup and boiled it up to get that rich marrow material into the soup. That's what we eat. And that's exactly what these worms are eating.
It takes the worms and other creatures around 100 years to consume a large blue whale. A single dead whale is so large that at the spot where it falls, it delivers as much food to the abyssal plain as 4,000 years of marine snow. To identify the creatures living on the bones, Vryenhoek's team need to bring some to the surface. Once on board, they identify and count the different species. They find that the whale's contribution to the ecology of the abyssal plain is enormous. 1 square yard of bones can support over 170 different species, some of which only live on dead whales.
This is all we're looking for.
On this single trip, the marine biologists discover 3 new species. It's confirmation of how little we know about the deep ocean.
The future of this work's pretty obvious. Every time we go out, we find something new.
Amazing samples.
Over the millennia, whale carcasses contribute to the thick layer of sediment that builds up at the bottom of the ocean. But it's not going to lie there forever. The vast abyssal plain is on the move. Like a giant conveyor belt, it's traveling from the mid-ocean ridge to the deep-sea trenches, and everything on it moves too. The wrecks of ships, dead animals, and whole islands. One of the best ways to measure how fast the seafloor is moving is to look above the waves and visit the world's most remote island chain, Hawaii. This is the Big Island. From base to summit, it's the biggest mountain in the world, nearly 4,500 feet taller than Mount Everest. Yet for all its size, it is on the move. The seafloor drags it along. The Hawaiian Islands sit on the abyssal plain, directly over a hot spot, a tear in the Earth's crust. Through this, molten rock, magma, surges up to form a massive volcano, the Big Island. These spectacular underwater lava flows show that the island is still growing, but not for long. The ocean floor conveyor is carrying the Big Island away from the hotspot. But in its place, another volcano will grow up, and then another, as the ocean floor moves over the hotspot. We can see the same process by passing a piece of paper over a flame. The Big Island is the latest in a long line of now extinct volcanoes to rise up on this spot. The most distant is now 3,600 miles away. It passed over the hotspot 85 million years ago. This means that the sea floor on which Hawaii sits is moving at an average speed of 3 inches per year. If Hawaii carries on moving at the same speed and in the same direction, in 64 million years, it will end up somewhere off the east coast of Russia. Eventually, the enormous island will slide into the mouth of a deep ocean trench. Now, our diver prepares to enter these terrifying chasms, the deepest, most dangerous parts of the ocean. We're about to discover that this remote alien world is the birthplace of some of the most violent natural phenomena on Earth. On our journey to the bottom of the ocean, we've encountered strange creatures, immense mountains, and vast, featureless deserts. But we've only skimmed the surface. Our diver is only halfway down. Now, we venture beyond the abyss to the deepest and deadliest part of the ocean, the mighty ocean trenches. It's an alien, inhospitable world that only a handful of people have ever visited. But what happens down here can have a dramatic effect on our world above the waves. 3.7 miles down, the ocean floor drops away. We're staring into what seems like a bottomless pit. These immense trenches are the deepest parts of the oceans, the deepest places on the planet. And the deepest trench of all is the Mariana Trench in the North Pacific, 200 miles southwest of Guam. It's so deep that only 2 people have ever attempted to reach the bottom. January 23, 1960, Navy Lieutenant Don Walsh and Swiss undersea explorer Jacques Piccard are shut inside a 150-ton steel sphere slung beneath their submarine, the Trieste. They dive beneath the waves and begin their journey into the Mariana Trench. It will take them 5 hours to reach the bottom. They pass ghostly bioluminescent creatures on their journey into the unknown. At 20,000 feet, one of the thick glass windows cracks. But drowning is the last thing on their minds. The pressures at this depth are phenomenal. If the vessel springs a leak, the water will come in so fast, it will slice straight through their bodies and kill them instantly. 5 hours after setting out, the Trieste lands with a bump at the bottom of the Mariana Trench. They are almost 7 miles below the surface. At first, there's no sign of life. But then there's a fleeting glimpse of a fish. It seems that even in these extremes, life can survive. But for the men, the hostile conditions make this a brief stay. After just 20 minutes, they return to the surface. Since then, over 400 people have traveled into space, but Walsh and Piccard remain the only two who have ever been to the ocean's greatest depth. The mission gives us an insight into the powerful forces that shape our planet. Because the process that created this trench also creates some of the most violent natural phenomena on Earth. The idyllic Caribbean island of Montserrat, home to 11,000 people and a popular vacation destination. June 25th, 1997. A plume of ash spews from the top of the island's highest mountain. Deadly avalanches of hot ash and rock force residents and tourists to flee. 19 people are killed. The Paradise Island is now a hell on Earth. It's a disaster from which it will struggle to recover. Volcanic activity means the seafloor is on the move. But unlike Hawaii, Montserrat is not a hotspot. The events of June 1997 are the result of a cataclysmic confrontation that takes place at the very bottom of the ocean's deep trenches. Montserrat lies on the edge of the Puerto Rico Trench, the longest, deepest trench in the Atlantic Ocean. The island owes its existence and its violent nature to the Earth's conveyor belt system. The mid-ocean ridge pushes the North American plate toward the Caribbean plate. When they meet, something's got to give. A process called subduction forces the North American plate down toward the Earth's core. As the plate descends deep into the Earth, it encounters intense heat and pressure. The pressure squeezes water out of the sediment carried down with the plate. It lowers the melting point of the overlying rock, which melts into magma, forces its way to the surface, and erupts as a volcano. Over millions of years, ash and lava pile up on the sea floor. Eventually, they break the surface to create volcanic islands like Montserrat. But for every volcano above the waves, there are at least 2 others hidden beneath them. 70% of the world's volcanoes are underwater. The Pacific Ocean has the largest concentration of underwater volcanoes, many in a 25,000-mile ring of fire that stretches around the ocean's edge. Today, Montserrat's volcano continues to erupt. Its former capital lies abandoned, and half the island is an exclusion zone. The process of subduction that created the island and now threatens to destroy it never stops. Over the next 200 million years, the subduction zones will suck in almost all the seafloor that exists today, consuming everything on it. The giant ocean conveyor belt will swallow wrecked ships, dead whales, and even whole islands, spitting them out later in violent volcanic eruptions. But this process isn't always a smooth one. On our journey to the bottom of the ocean, we're about to witness what happens when the conveyor belt gets jammed. It's the most terrifying demonstration of the ocean's power, the source of tsunamis. On our journey to discover what lies at the bottom of the sea, we're in the deepest part of the ocean, the deep ocean trenches. It's 7 miles down, as far below the waves as a jet plane flies above them. The ocean floor, born in the furious heat of the mid-ocean ridge, carried by the seafloor conveyor thousands of miles across the face of the Earth to meet its end in a deep ocean trench. Joined end to end, the ocean trenches stretch for at least 6,000 miles. Almost every 4 million years, they swallow up an area of seafloor the size of the United States. But the seafloor doesn't go quietly. Its end is one of nature's most violent processes, an event so powerful it can be felt thousands of miles away. December 26, 2004. Another perfect day dawns on the beaches of the Indian Ocean. But hundreds of miles out to sea, deep beneath the surface, the giant ocean conveyor belt is about to unleash its awesome power. The Deep Java Trench. Here, friction stops the India Plate from moving smoothly beneath the Burma Plate. Tension has been building between them for centuries. Now, it's about to give. All the elements are in place to create a megaquake. One so large, it will trigger a monster wave, a tsunami. Jose Barrero from the University of Southern California Tsunami Research Group studies the forces that create these killer waves.
The key components for a killer tsunami are a huge earthquake, deep water, and lots of motion on the seafloor.
To trigger a tsunami, scientists think the earthquake has to be enormous, at least a 7 on the Richter scale.
The bigger the earthquake, the bigger the tsunami wave is going to be.
7:58 a.m., December 26, 2004. The Burma Plate suddenly lurches 50 feet upward. Tension that has built up over centuries releases in seconds. Along 750 miles of subduction zone, the seafloor rears up. It triggers an enormous earthquake, 9 on the Richter scale. Estimates put the energy released as equivalent to 100 gigatons of TNT. That's more than 6 million Hiroshima atomic bombs. The violent movement pushes 7 cubic miles of water upward. This displaces the water at the surface and forces it out away from the earthquake's epicenter. A massive wall of water surges outward at the speed of a jet aircraft. It will reach these tranquil beaches in less than 1 hour. In deep water, a tsunami can travel at 500 miles per hour. But as it reaches shallower water, the wave slows down.
This slowing down is what makes the tsunamis actually more deadly, because as the front end of the wave slows down, the back end of the wave is still coming in, and it's like a gigantic train wreck. The front end stops, and the back of the wave piles into it, and you've got this massive increase in water level, and the sea level rises and destroys everything on the shore.
Just 15 minutes after the earthquake, the tsunami wave hits the Indonesian coast. Within 2 hours, it reaches Thailand and Sri Lanka. In 8 hours, it reaches Africa. It is the most devastating tsunami in recorded history. And one day, somewhere else on our planet, it will happen again. On the surface, the ocean is often calm, a place to relax. It's easy to forget about the powerful forces at work miles below. It's time for our diver to leave the deep behind. From the bottom of the deadliest, deepest trenches, Across the vast abyssal plains, over the furious inferno of the mid-ocean ridge, to the strange underwater pools of the continental shelf, we've discovered a remote alien world that has a direct and dramatic effect on our life above the waves. So far, scientists have explored just 10% of the ocean's depths. Out there somewhere are bizarre new creatures and awesome natural wonders just waiting to be discovered in the vast hidden world of the deep.